Welcome to Geology, Life, and Healing. This is Sebastian Mayapaz. I'm from Tucson, Arizona, United States, and you're in your channel, Geology, Life, and Healing. And this time we're going to see how to estimate total copper from chalcocite and porphyry copper deposits. And like always, this is dedicated for the students who are in the last years at the university or the students who are already finishing. They're looking for the first job in the porphyry copper deposits. Okay, and this question it might show up or it might not show up in the last interview you would have in the mine site. So they're going to take you to the field, and if you take it with you the hand lenses, so you can make it in the interview. There's some question like that. They're going to give you a rock sample in your hand or in the field or on the core, and they're going to say how much copper you estimate in here. That's going to be your question. And then one last thing as a disclosure, it's there are formulas, there are charts, and many other tools to estimate total copper from any rock, any mineral. And I'm not going to show those because those belongs to some company, private property. So those I'm not going to show those. Something I'm going to show is how you can calculate it, something that you're going to use from from what you have, minerals, rock books, and from there. Okay, let's start it. So in this case, I have the sample sent by Manuel. Thank you. Manuel is a subscriber to this channel. Yeah, we have some chalcocite disseminated in here, a little bit in there, veinlet, right? And next one, chalcocite banded in here. It's another side, another face of the same sample. This is the disseminated area that we have is in this case, in this area. So we have some clays, maybe some cerussite, I don't know, but we don't have chalcocite in here, we don't have chalcocite over there, and this is going to we are going to consider as a vein too. So it's not going to consider as a disseminated. We don't have disseminated there in here. So how to estimate, how to make the estimate of total copper in 3 steps. One, you need to use a chart. And in this case, I'm going to use the AGI data sheets for and calculate the spatial percentage and disseminated and veinlets. Okay, the same as you can do in your with a microscope or hand lenses, and that's this is the chart that we're going to use it, and this is the reference. And number two, the percentage of the image that we see in the rock, in the core, and reverse circulation chips and plastic chips, we are going to compare. We're going to make an estimation, and we are going to be ready for the third part. The third point is make the approximation. So from the chemical formula, we have we can obtain chalcocite, obtain total content of copper is 79.8%. So for our purpose, we'd say we round it 80%, okay? And then we make the approximation as a reference. If we have 1% spatially, spatial percentage in the microscope or the hand lenses, we'll make, the estimation will be 0.8%. So that's what we want to work. In 1%, 80% of copper. That's going to work. And then we go, right? This is the veins, this is the disseminated, and this is the another vein too, right? That's what we saw. And then we compare, right? This is the chart we have. This is how you will see the dots in your microscope or in your hand lenses. So we have a group in here. This group is going to be 1% too. So the only difference is we have a group. We have 5 groups in here, and this is separate disseminated grains. Okay, so we take that one and we go to the next one. So we have the chart, we compare. So if we move, this one or that one to this space, so and put it in here, that's going to be very clearly very close to 1%. And if we put in here, it's going to be very close on the 1%. So it's another. So all this space is going to be the value of 1%. That's going to happen. But all the rest of the area is not going to be 1%. So something in my imagination, I'm just distributed the dots in the whole maybe 13 centimeters of this sample. So I put it, so it's going to be only 0.5% of volume. And then see, if it's if 1% it was 0.8 total copper, so in this case half will be only 0.4%. Okay, so now we see the veinlets. They have this veinlet, another veinlet, this is the veinlet, and so it looks way more than disseminated, but in the reality, all this veinlet is usually less than disseminated. There is some reasons, and there is a way to calculate it also that I'm not gonna show those, right? And so at the end, something gonna happen. It's I have 0.4% of copper as a disseminated, and I have zero point 0.4 copper as a veinlet. So the total copper or calculated or estimated copper is going to be 0.8. And and if you go to this interview, you are in the field, they put a sample and everything, and you make an estimation. You explain how you did it. I think yeah, you will pass your test, your exam. And the other thing you have to consider in order to calculate all these numbers, it's the size of your sample. It's going to be, our case, 15 centimeters, but you'll have 5 feet, 10 feet. 10 feet of sample. So if you have to change it and move around and say how much will be total. So in total for you, that's the number you want to give for your copper estimated. And chips going to be easy because everything broken, you consider everything as a disseminated. Okay, and the blast holes, of course, the length of your sample will be 50 feet, right? It's going to be just one sample, but for 50 feet. And then next time, the video will be about kaolin type gold deposits. Okay, you have to see it. Thank you, thank you, thank you.